So वेलकम टू लेक्चर सीरीज ऑन डिज़ाइन ऑफ मशीन एलिमेंट्स यूनिट 3 पावर स्क्रू। आज हम इस लेक्चर में नवंबर दिसंबर 2024 का क्वेश्चन 1B क्वेश्चन देखेंगे। दिस इज ऑन पावर स्क्रू। प्रॉब्लम इज इन दिस वे, अ मशीन वाइज एज शोन इन फिगर हैज अ सिंगल स्टार्ट स्क्वायर थ्रेड्स विथ 22 mm नॉमिनल डायमीटर एंड 5 mm पिच। मशीन वाइज है जिसमें स्क्वायर थ्रेड का स्क्रू यूज किया है जिसका नॉमिनल डायमीटर है 22 mm एंड पिच है 5 mm. The outer and inner diameter of the friction collar are 55 mm and 45 mm respectively. Outer and inner diameters of the friction collar are DO and DI are 55 and 45 mm respectively. The coefficient of friction for the thread and collar are 0.15 and 0.17 respectively. Coefficient of friction for the threads and for collar friction are given this value. Mu is equal to 0.15 and mu c is equal to 0.17. Mu c means collar friction, coefficient of collar friction. And mu is nothing but the coefficient of friction for the thread surface. The machinist can comfortably exert a force of 125 Newton on the handle at a mean radius of 150 mm. तो मशीनिस्ट यहाँ पे हैंडल पे फोर्स अप्लाई कर सकता है, यहाँ पे फोर्स अप्लाई कर सकता है 125 न्यूटन का, एंड दिस फोर्स इज अप्लाइड एट द रेडियस ऑफ 150 mm. So force into radius, that is nothing but the torque applied on the screw through this handle. So here this is the example of a machine vise. Machine vise has a fixed jaw and moving jaw. Moving jaw is connected to the screw and the screw is connected to the handle. The torque is applied to the handle. So force of 125 Newton is applied on the handle at a radius of 150 mm. So that creates a torque, and rotary motion of the handle is converted into axial motion of the screw. And this moving jaw is moved forward and backward to apply the clamping force on it. So, assuming uniform wear for the collar, calculate the clamping force developed between the jaws. यूनिफॉर्म वेयर थ्योरी के हिसाब से यहाँ पे क्लैंपिंग फोर्स कितना डेवलप होगा दो जॉ में, तो वो फोर्स हमें कैलकुलेट करना है इस प्रॉब्लम में. एंड दूसरा आंसर ओवरऑल एफिशिएंसी ऑफ दिस क्लैंप, ओवरऑल एफिशिएंसी हमें कैलकुलेट करना है. ये 12 मार्क के लिए प्रॉब्लम आया था नवंबर दिसंबर 2024 क्वेश्चन पेपर में से, ये क्वेश्चन 1B है. तो यहाँ पे हम गिवन डेटा लिखेंगे. प्रॉब्लम का गिवन डेटा क्या क्या है? प्रॉब्लम का गिवन डेटा है, इट इज अ सिंगल स्टार्ट स्क्रू. सो फॉर सिंगल स्टार्ट स्क्रू N is equal to L, number of starts is equal to lead. So for single start screw, L is equal to N into P. For single start screw means in one rotation of the handle, the screw advances by distance equal to pitch. So L is equal to N into P. P is the pitch. So here N is equal to 1. So for single start screw, L is equal to pitch, and pitch is given in the problem, that is 5 mm. So we can write the pitch P is equal to 5 mm for this problem. So lead L is equal to also 5 mm. Lead is the distance the screw axially advances with one rotation of the handle. Lead screw advances by distance equal to one pitch, and that is called as the lead. For single start screw, L is equal to P. So here the L is equal to also 5 mm, and the nominal diameter of the screw is denoted as a small d. D is nothing but the nominal diameter of the screw. And that is given 22 mm. Nominal diameter दिया हमें 22 mm. Nominal diameter is 22 mm, and pitch is 5 mm. The outer and inner diameter and inner diameter of the collar are given. So DO is nothing but the collar outer diameter, that is OD. So DO is given 55 mm. DO is 55 mm. So the outer radius of the collar, that is denoted as RO. RO is half of this, so it is 27.5 mm. So outer radius of the collar is RO is equal to 27.5 in this problem. Now DI is the collar ID, collar inner diameter, and that is equal to 45 mm. So inner radius of the collar, that is RI is 22.5 mm. 22.5 mm. This is the RI. Now coefficient of friction between threads of the screw and nut, it is given 0.15, and coefficient of collar friction, that is mu c is 0.17, and the machinist can exert a force F, force applied on the handle by the machinist. F is nothing but the force applied by the machinist force applied by the machinist at the handle, and that force F is equal to, that force is equal to 125 Newton, 125 Newton, and this force is applied at a mean radius. This force is applied at a mean radius, that is Rm. So R is the mean radius of the handle, mean radius of the handle, that is given 150 mm. So mean radius of the handle is 150 mm. So R is equal to 150 mm. तो हमें इस प्रॉब्लम में क्या कैलकुलेट करना है, क्लैंपिंग फोर्स और ओवरऑल एफिशिएंसी हमें कैलकुलेट करना है। क्लैंपिंग फोर्स और ओवरऑल एफिशिएंसी इस प्रॉब्लम में हमें कैलकुलेट करना है। तो पहला स्टेप हमारा ये रहेगा, कैलकुलेट द वेरियस थ्रेड पैरामीटर्स। कैलकुलेट, वेरी फर्स्ट स्टेप इज टू कैलकुलेट द वेरियस थ्रेड पैरामीटर्स। Very first parameter is the mean diameter of the screw. Mean diameter of the screw, that is DM. Mean diameter of the screw is calculated as nominal diameter minus pitch by 2. Nominal diameter minus pitch by 2 is the mean diameter. So mean diameter we can calculate. Nominal diameter is given in the problem, that is it is given nominal diameter is 22 mm. So 22 minus pitch is 5 mm. So 5 by 2, 2.5 mm. 22 minus 2.5. So this diameter, mean diameter of the screw, we can calculate as a 19.5 mm. Mean diameter of the screw is 19.5 mm. Now the lead of the screw, as it is a single start screw, lead of the screw, that is L. यह हमें कैलकुलेट करना है। L का फॉर्मूला है L is equal to N into P, where N is the number of starts. So for single start screw, N is equal to 1. So L is equal to P, and pitch is 5 mm. So lead of the screw is 5 mm. Lead of the screw is 5 mm. Then we have to calculate the helix angle or lead angle. Helix angle or lead angle, or it is also called as a lead angle, lambda. So tan of lambda is equal to lead divided by pi into dm. Lead divided by pi into dm. So that is equal to lead is 5 mm divided by pi into dm is 19.5. So we get this tan of lambda value. Tan of lambda value is 5 upon pi into 19.5. ये वैल्यू कितना रहा, 0.8162. We'll mark this as equation 1. tan of lambda का वैल्यू इतना है, फिर हमें कैलकुलेट करना है फ्रिक्शन एंगल phi. So friction angle phi is calculated as coefficient of friction, thread friction is given to us. So mu is equal to tan of phi. So mu is given 0.15 in the problem, that is equal to tan of phi. कोएफिशिएंट ऑफ फ्रिक्शन दिया है हमें, थ्रेड फ्रिक्शन दिया है 0.15, तो यहाँ से हमें tan of phi का वैल्यू मिल गया, tan of phi is equal to 0.15. Suppose this is equation 2. Then we have to calculate the mean collar radius, or as per the uniform wear theory. In the problem it is stated that calculate the force applied by the machinist, or clamping force required to clamp the workpiece. तो हमें यूनिफॉर्म वियर थ्योरी के हिसाब से मीन रेडियस कैलकुलेट करना पड़ेगा, कॉलर का मीन रेडियस कैलकुलेट करना पड़ेगा. सो कैलकुलेट द मीन रेडियस. So we'll say this is the step 2. Calculate the mean radius of the collar. Collar is of inner diameter di and outer diameter do. So it is of inner radius ri and outer radius ro. So as per uniform wear theory, the mean radius of the collar is taken as Rm is equal to ro plus ri divided by 2. So the mean radius of the collar, that is Rm is equal to ro plus ri divided by 2. RO plus RI divided by 2. So RO we have calculated in the initial step, and that was RO is 27.5 mm and RI is 22.5 mm. So 27.5 is the RO value and 22.5 is the RI value. So 27.5 plus 22.5 RO plus RI divided by 2. So mean radius of the collar RM is equal to 25 mm. It is equal to 25 mm mean radius of the collar as per uniform wear theory. फिर तीसरे स्टेप में हमें कैलकुलेट करना है टोटल टॉर्क अप्लाइड एट द हैंडल. Total torque applied by the machinist at the handle, ये हमें कैलकुलेट करना है. So total torque T is equal to the force F into radius R. Force F is 125 Newton is the force applied by the machinist, into R is the radius of the handle. That is given in the problem. 125 Newton is the force applied to the machinist at the handle and 150 mm is the radius of the handle. That is given in the problem. So we can find out the torque value as 18,750 Newton into mm. This is the torque applied by the machinist at the handle in Newton mm. Now next step is to calculate the torque required to overcome the total torque required to overcome the thread friction as well as collar friction. So total torque T is equal to T suffix T plus TC. TT plus TC. TT is nothing but torque required to overcome the thread friction, and TC is nothing but the torque required to overcome the collar friction. So where we can write where TT is nothing but torque required to overcome the thread friction. Between screw and nut, thread friction, and TC is nothing but the torque required to overcome the collar friction. So we have to calculate the torque required to overcome the thread friction. It is given by formula W into tan of 5 plus lambda into mean diameter divided by 2. So effort into mean radius is nothing but the torque required to overcome the thread friction. So putting the value, so we can calculate T suffix T. W that we have to calculate clamping force. W we have to calculate tan of 5 plus lambda can be written as tan of 5 plus tan of lambda. This is the formula for tan of 5 plus lambda. Tan of 5 plus tan of lambda minus upon 1 minus tan of 5 into tan of lambda This is the formula for tan of 5 plus lambda and multiplied by mean diameter divided by 2. This way we can calculate the torque required to overcome the thread friction is equal to W multiplied by tan of 5. This value we have calculated. We can see tan of 5 this value is 0.15, and tan of lambda also we have calculated in the beginning. So tan of lambda is this value. Tan of lambda is 0.8162 and 0.15 is the tan of 5 value. So tan of 5 value is 0.15 plus tan of lambda is 0.8162 and divided by 1 minus 0.15 into 0.8162. This is in the bracket, divided by mean diameter of the screw that we have calculated in the beginning, and that is 19.5 is the mean diameter. So 19.5 is the mean diameter divided by 2. So in this way, we get this torque required to overcome the thread friction. So this comes out, the calculation, it comes out 2.282854 times of W. In terms of W ये आंसर आएगा. इसको इस इक्वेशन को बोलेंगे इक्वेशन 3. So torque required to overcome the thread friction is in terms of the clamping force W. Here W is nothing but the clamping force on the moving jaw or on the workpiece. Now second one is to calculate the torque required to overcome the collar friction. So torque required to overcome the collar friction is formula is mu C into W into Rm. So if we put the values, torque required to overcome the collar friction mu C is given 0.17 multiplied by this force is W into mean radius. Just now we have calculated the mean radius of this collar. Mean radius of the collar as per uniform wear theory, it is RO plus RI divided by 2, that is 25 mm, that we have calculated. So we have to take this value here for the calculation. So TC is equal to this answer comes out 4.25 multiplied by W. 4.25 times of W. W is the clamping force here exerted on a moving jaw, exerted by the moving jaw in the forward direction. So the total thread friction. Now we can calculate the total torque required to overcome the friction. Total torque T is equal to TT plus TC. Total torque हमने calculate किया है. Total torque कितना है? Total torque applied by the machinist at the handle is 18,750. So putting the values here, 18,750 is equal to torque required to overcome the thread friction. This value is 2.2854 into W plus collar friction torque is 4.25 times of W. तो यहाँ से हमें W का that is clamping force का वैल्यू मिल जाएगा 18,750 डिवाइड बाय 6 पॉइंट, ये दोनों का एडिशन 2.2854 प्लस 4.25 इन दोनों का एडिशन आएगा 6.5364. तो क्लैंपिंग फोर्स का वैल्यू हमें मिल जाएगा. क्लैंपिंग फोर्स का वैल्यू मिल गया 2868.55 न्यूटन. ये आंसर है इस प्रॉब्लम में हमारा. ये आंसर है क्लैंपिंग फोर्स. इस प्रॉब्लम में इतना है क्लैंपिंग फोर्स. Clamping force developed between the jaw is this one. This is our first answer. Now second answer is to calculate the overall efficiency. So we can say fifth step, calculate overall efficiency. Overall efficiency of this screw. Overall efficiency का formula है eta is equal to work output upon work input. Work output upon work input ये formula है इसका overall efficiency का. Work output is given by W into L divided by 2 pi into T. T is the total torque. So overall efficiency is calculated as the clamping force. Clamping force is this. W is the clamping force. W clamping force है not axial load. Clamping force here. So it is 2868.55 Newton multiplied by L. L is the distance through which the this force is applied. That is L is equal to 5 mm divided by 2 pi into total torque T. Total torque applied at the handle is 18,750. So this comes out 0.12175. That means 12.17%. So overall efficiency is here 12.17%. This is our second answer for this problem. The overall efficiency of the screw is 12.17%. So this is about the problem on the machine wise, which is of a square threaded screw, and this screw is of a single start screw. In this way the problem हमें complete करना है. So thank you very much. See you in the next lecture on another important problem from the PYQs on this power screw. Thank you.